Now the heat diffusion equation in cylindrical coordinate system. Just like we had this heat flux in x, y and z dimensions in Cartesian coordinate system as k dava t by dava x, k dava t by dava y and k dava t by dava z. Now when it comes to the cylindrical coordinate system, instead of having x, y and z, we have r, z and phi. We have r, z and phi, where r is the radial direction or dimension, z is the dimension along the length of the pipe, and phi is an angle. Let's say that where is r, where is z and where is phi. This is the diagram that is given in the book. Of course we would not be I am leaving the derivation of this thing on you, and this derivation would be the same as the derivation or very similar to the derivation of the Cartesian coordinate system equation. You can see that there are three axes. We do not have x. We had x, y and z in case of plane wall Cartesian coordinate system, but now we have got r axis, we have got z axis and we have got phi axis. I will just explain it in a bit, what do those axes mean, because it is very important that we understand those axes. And if you work the things out, if you derive it yourself, you will get this equation: 1 over r dava by dava r of k r dava t by dava r plus this quantity, plus the third quantity, which is the same that we had in the Cartesian coordinate system. So this is the heat diffusion equation in cylindrical coordinate system. Kindly do not get overwhelmed by this heat diffusion, by this complex looking heat diffusion equation. I would advise you to at least remember its first term only: 1 over r dava by dava r of k r dava t by dava r plus q dot is the same as the term that we had in the Cartesian coordinate system, and the right hand side, which is rho c dava t by dava t, is also the same term that we had in Cartesian coordinate system. If you do so, you would not be required to refer back and forth to this complex equation. We will see the advantage in a little bit. Now see what is meant by those three axes. We have got an r axis, we have got a z axis, and we have got a phi axis. So let's start with z axis. Let's start with z axis. So if this is a pipe carrying steam, right, and if the steam is flowing in this particular direction, so that would be its z axis, means along the length of the pipe. Similarly, while the steam is flowing in this direction, so this would become its z axis along the length of the pipe. So that is pretty simple. So now if you are told that the steam is flowing at 500 degrees Celsius, it means that while the steam is flowing along the length of the pipe, its temperature is more or less constant at 400 or at 500 degrees Celsius. So if this is so, then the temperature will not vary in z direction. Then the temperature will remain the same in z direction. It will not be a function of z in this particular case. However, if the steam is flowing through a particular pipe and its temperature is continuously increasing or decreasing, then of course the temperature will vary in z direction. Now phi, or let me first explain phi. Phi is an angle. There are two linear terms. R is linear, Z is linear, whereas phi is in fact an angle. So that angle is, for example, if you traverse on the, if this is a pipe, right, and if you traverse this way on the pipe, means if you traverse in an arc, along an arc, so if you move along this arc, so this arc would have a length of s, if you recall, s is equal to r theta, and this arc will subtend. I do not want to draw it, but you should visualize that this arc will subtend at angle at the center of this pipe. This arc will make or subtend an angle on the center of this pipe. Now that angle is phi. That angle is, you can say, phi. So what does this mean? It means that if there is a change in temperature along the length of this arc, so then we will say, or you can say circumferentially, so then this would mean that temperature is varying in phi direction. Then we will say that the temperature is varying in phi direction. What happens usually if you touch a pipe and suppose it is not that hot, or it is wrapped in insulation, so then it won't be that hot, and if you find the temperature at this point the same as the temperature at this point, so we will conclude that temperature over here is not varying circumferentially, means temperature will not vary in phi direction. And if we find a difference, it means that temperature is varying in phi direction. So this is what is meant by z-axis, along the length of the pipe, along the axis of the pipe, and this is what is meant by phi axis. The last thing is r, radial direction. In radial direction, if, for example, let's start with those pipes. You can see that there is an inner surface of the pipe and then there is an outer surface of the pipe, and this is the thickness of the pipe. So if at inner surface the temperature of the inner surface of the pipe is, for example, so suppose that if the temperature of the inner surface of the pipe is 500 degrees Celsius, the same as the temperature of the steam. So the we know that the heat will flow from higher temperature to the lower temperature. So if inside this pipe is steam at 500 degrees Celsius, and if we assume that the temperature of the inner surface of the pipe is almost the same as that of the steam, means 500 degrees Celsius, so when the steam will flow, when the heat will flow outwardly in this direction, so the temperature of the outer surface of the pipe will be less than the temperature of the inner surface of the pipe, means the temperature at the outer surface of the pipe will be less than 500 degrees Celsius. So if we suppose that it is 300 degrees Celsius. So what does this mean? It means that at different radii the temperature has got different values. At inner radius it is 500, at outer radius it is 300, and in between it would be less than 500 and more than 300 degrees Celsius. So it means that if we move in radial direction means at different values of r, the temperature, if the temperature is having different values, then we will say, or then we will conclude that yes, the temperature is varying in radial direction, and therefore the temperature is a function of r. This is what it means. This is what T is equal to function of r means. So the heat will flow out radially, which is being shown over here. The heat will flow out radially in all the directions. It will flow out. The heat will flow out radially in all the directions. Now over here we are being shown for example, if this is steel, if it is a steel pipe, then the temperature difference across the thickness of the pipe, through the thickness of the pipe, will be less. Why? Because steel is a good conductor. However, what we usually do is that we wrap the steel pipes in insulation so as to reduce the heat loss. So what will happen now is that this pipe becomes, see, there are two advantages. Number one, the heat loss reduces to a minimum. Number two, putting a pipe in an insulation makes it a safe to touch environment. It prevents accidents, because if you now touch the outer surface of the pipe, in this case you will not feel that the pipe is hot, because you are not touching the pipe, but you are touching in fact the insulation. So the outer surface of this insulation will not be as hot as the outer surface of this pipe. So what happens now is that the temperature at the outer surface of the insulation would be approximately like 35 or 40 or 45 degrees Celsius, whereas on the inner surface of the insulation or outer surface of the pipe, the temperature was 300 degrees Celsius, as we were discussing over there. So over here the temperature will reduce a lot from 300 degrees Celsius to about 30-35 degrees Celsius, almost the environment temperature, outer environment temperature. It means that there would be a large temperature gradient across this thickness of insulation. There would be a large temperature gradient, there would be a large temperature difference across this thickness of insulation. Why? Because insulation is insulator. It is not a conductor. So it will offer very high resistance to heat flow. Therefore, there would be a large temperature drop. So again, at this radius we would have a different temperature, and at this radius there would be a different temperature. So therefore T would be a function of R. T means a different radii at different values of R. The temperature would gradually reduce to the temperature of the surrounding air. So this is what is meant by the radial direction, the z direction, and the phi direction in cylindrical coordinate system. Now the heat diffusion equation in spherical coordinate system. This is the heat diffusion equation in spherical coordinate system. Of course it is quite cumbersome, but again I would advise you to remember by heart the first term only. 1 over r square dou by dou r of k r square dou t by dou r plus q dot is rho c dou t by dou t. See, there is a reason. Over here when we were discussing the cylindrical coordinate systems, see what happens that if you check the temperature along the length of the pipe carrying steam, you will not find different values of temperature at different points. It means that temperature is not a function of z. Similarly, you will not find the temperature to vary circumferentially, means temperature is not a function of phi even. So what happens is that if there is a pipe carrying steam or any other heat transfer fluid, the temperature is usually a function of R only. And if it is a function of R only, it will make it a one-dimensional heat transfer case. So therefore, what is the heat diffusion equation then? The first term, which was 1 over R dou by dou r of, let me show you, dou by dou r of k r dou t by dou r plus q dot is rho c dou t by dou t, right? So you can deal those equations very easily if it is one-dimensional heat transfer problem, and especially if it is radial dimension heat transfer problems. It means that if temperature is changing radially only. The same thing happens over here. Most of the times if we would be dealing with the temperature variation in radial direction, and therefore the first term plus q dot is equal to rho c dou t by dou t would be sufficient. Now in spherical coordinates there are again three parameters, r, phi and theta. r, phi and theta. So we have seen r before in cylindrical coordinate system. We have seen phi before in cylindrical coordinate system. Now we are seeing theta. So see, there were three linear dimensions in Cartesian coordinate system: x, y and z. In cylindrical coordinate system, those three linear dimensions became two linear and one angular. And over here in spherical, we have got one linear and then there are two angular, phi and theta. Now what is r, what is phi and what is theta? Consider a cricket ball which is a sphere, and consider that you are at the center of this ball, and if you start moving from the center of this ball to the outer surface, means if you end up anywhere around this seam, so this is movement in the radial direction, and if temperature is changing in this direction, we say that temperature is a function of r. Temperature is changing radially. Now the second is phi and the third is theta, two angles. So let me show you what those two angles are. For example, if you move along this seam, if you move along the seam of this ball, of course it will draw an arc on the ball, and this arc will subtend, this arc will make an angle on the center of the ball. That angle is one angle, such as phi. Now the last angle, the second angle, which is theta. If you do not move along the seam of the ball, but if you move in this direction, if you move in this direction, then again it would be a curve. Then again it would be a curve. And if you this curve, this arc will subtend, or it will make an angle onto the center of this ball. That is the second angle. So radial direction, one angle, and then we have got the second angle. Let me give you one more example. Igloo, right? Now radial direction was pretty much simple, but igloo is made of various bricks, right? And brick has got two dimensions, one along this axis, horizontal you can say, and one along vertical axis. So if you traverse from this point to this point, if you move from this point to this point, it will generate an arc, and this arc will subtend at an angle. That angle is one of the angles, theta and phi. Let's say it is phi. Whereas if you move in this direction, right, from this point to this point, now that is also an arc, and this arc will subtend another angle onto the center point of this sphere, and that angle is the second angle. You may call it theta. So radial direction, phi direction and theta direction. Now the last thing before we end our discussion of the three coordinate systems and start solving the numericals, this figure would be familiar to you. If you cut a cylinder, it becomes a flat surface, right? A flat surface means we are talking about Cartesian coordinate system. Kindly listen to this very carefully. It means that we are talking about a Cartesian coordinate system. Cartesian coordinate system means three lengths, x, y and z, just like your register, your writing pad, right? So if you write on that register, it is a Cartesian coordinate system. However, if you roll your register, it becomes a long cylinder. Means those three axes, those three linear axes x, y and z, if we end one of the linear axis and roll it and make it circular, so therefore it becomes a cylinder. So it will convert it from x, y and z, three linear, into two linear and one circular, r, z and phi or theta, whatever you want to call it, phi as per our discussion. Now, can you convert this cylinder into a sphere? This is the question. Can you convert this cylinder into a sphere? Can you imagine doing that? If you try to roll this cylinder from here to here, from the top surface to the bottom surface, you will visualize that it will take the shape of a sphere. Means that if we try to end the axis of the cylinder, if we try to make the axis of the cylinder vanish, go away, then it will take one more linear axis out and it will bring in one more angular axis. So how many angular axes did we have in spherical coordinates? 2, right? So starting with Cartesian and giving it one roll would make it cylinder, and giving the cylinder the second roll will make it a sphere. So from x, y, z into r, z and theta, and then r and two angles, phi and theta.